One of the largest hurdles the blockchain industry is constantly working towards is this end goal of reaching mass adoption. This is no easy feat, and some might think that flashy commercials with Matt Damon or even government officials endorsing the industry is enough to take us to the promised land. Now, while all of that certainly does help elevate the perceived value of adoption in the industry, what will truly solidify blockchain tech into the eyes of the masses is one word: simplicity. You see, blockchain tech needs to evolve beyond just speed, decentralization, and tokenomics. The key is creating an experience so seamless that users don't even realize they're interacting with blockchain tech. Look at your debit card, for example. You simply tap, swipe, or insert the card at the machine, and magically money is withdrawn from your account. Or even your car. While some know the ins and outs of what's going on under the hood, the majority have no clue, let alone know how to change a tire. But that's of course what mechanics and AAA are for. The point is, the same applies to blockchain. Until we get the user experience simplified, the masses will be reluctant to adopt. This blockchain is none other than Sui, and its unique approach could play a major role in driving mainstream adoption to an unprecedented scale. But what makes Sui so different, and how does it stand out in the evolving blockchain landscape? For starters, Sui is a layer 1 blockchain designed for high scalability, instant finality, and user-friendly applications. For those that don't know, high scalability just means it's designed to handle a huge number of users without slowing down. And as for instant finality, this just means it confirms transactions almost instantly. Simply put, it's built to be fast, efficient, accessible, even for people who don't know anything about crypto. But that's just the start. The core innovation of Sui is that unlike traditional blockchains such as Solana that track account balances, Sui uses an object-based data model. This makes assets programmable and more efficient. Think of it like this: on most blockchains like Solana, your crypto is just a number in a ledger, similar to how a bank tracks your balance. This is called an account-based model. But on Sui, every coin, NFT, or smart contract is treated like a unique digital item that can have its own properties and rules. This makes transactions faster, more efficient, and more flexible, allowing developers to create more advanced and user-friendly applications. Now at this point, I know some of us are thinking, I've used Solana before, and it's still pretty fast compared to other chains like Old Man Ethereum or Mac Daddy Bitcoin. And while this is true, the issue really lies in the way that Solana processes transactions compared to Sui. And though this may not seem like much now, it's going to really impact everyone down the road. For example, maybe you're trying to make a transfer to cash out some profits, but everything is slowed down because the user base has scaled so much. Imagine this scenario: it's late 2025 and let's say Solana reaches an all-time high of, I don't know, $1,000. You're absolutely ecstatic, as at these prices you finally have exactly enough to pay off all your credit cards or buy that car or buy that land, whatever you want to do. However, when you go to your wallet of choice and try to cash out on your Solana, you can't because the network is experiencing an outage due to extreme amounts of traffic. The token's price then starts to fall, and by the time the network is back up, it's worth far less. And when you do finally cash out, you make significantly less than you should have. And while this is just a silly scenario for our situation, let's think about what mass adoption would look like. If this happened in the real world, where banks, institutions are all relying on a network to stay up and running, and one day it just happens to go down, we are talking about potentially trillions of dollars of economy being affected in a big way. And that simply can't happen. So until these issues are resolved, we are going to have drastic reluctancy from institutions, from corporations, from Wall Street, from the average individual wanting to get deeply involved in these technologies. As you can tell by now, we're comparing Sui to Solana because they're honestly identical in many ways. But like many other blockchains, Solana uses a single global state where transactions are processed sequentially. In other words, Solana processes transactions one at a time in a single line, which can slow things down during high network traffic. This is because since all transactions happen in a strict order, validators must process them one by one, ensuring that each update to the blockchain is consistent across the network. So if one part of the network slows down, the entire system can be affected because every transaction depends on the previous one being confirmed first. The danger of a single global state system is that they create what is called a bottleneck, meaning if transaction volumes spike, validators struggle to keep up, which can lead to network congestion, downtime, and reduced scalability. SUI, however, uses parallel transaction execution, meaning that individual transactions can be processed simultaneously without having to wait in line. Not only does this make SUI faster and more efficient during busy periods, but it also makes it less likely for gas fees to spike amidst high network activity. The SUI network itself is powered by the project's token, which is also called SUI, just like how Sol does for Solana. It's used for staking, transaction fees, and governance. However, SUI's transaction fees remain ultra low, thanks to its parallel execution model and efficient storage system. Solana also has low fees, but because it processes transactions sequentially, network congestion can cause fees to spike unpredictably. This makes SUI technically the more scalable and cost-stable blockchain for developers and users. This means transactions are confirmed almost instantly, typically within 300 milliseconds with no risk of reversal. Solana, on the other hand, requires multiple confirmations before a transaction is fully settled, leading to potential delays and a higher risk of transactions getting reversed. For this reason, SUI is far more ideal than Solana for real-time applications like payments, gaming, and DeFi, where instant confirmation is absolutely crucial. This is because due to instant transaction finality, SUI eliminates mempool delays, which is what happens when transactions get stuck waiting in line before processed by the blockchain. Outside of instant transaction finality, with SUI's previously mentioned object-based data model, there is a far lower risk of congestion and conflicts when executing smart contracts during times of high network traffic. This means that SUI is way less prone to outages like those that have plagued the Solana network since its inception. And even though the Solana team has done things to reduce the likelihood of network outages, they still haven't 100% removed the possibility that more can happen. In fact, since the inception, the Solana network has had as many as 10 major or partial outages, with the last one occurring only a year ago in March 2024 and lasting multiple days. Anyway, for all those reasons, SUI is a much faster and reliable blockchain for institutions to adopt in the future compared to Solana and others like it. But to return to our initial point, institutional adoption is great, but what exactly is SUI's grand plan to achieve mass adoption for Web3? And why exactly are they so qualified to make it happen? Unlike most Web3 blockchains that focus primarily on serving crypto native users, SUI was instead designed with the goal of bringing blockchain technology to the masses. And this is no coincidence, as it was built by former Facebook engineers who previously worked on a project called Dime. This was Facebook's ambitious but ultimately abandoned blockchain project, which was designed to onboard billions of Web2 users into Web3. However, even though Dime failed, the team's experience designing it gave them deep insight into exactly what it takes to build a blockchain that can scale to mainstream adoption. And they literally did this from the ground up at almost every angle imaginable. So let me quickly break down how this is. SUI was created using a relatively new programming language called Move. What makes Move unique is that it was specifically designed for smart contracts and blockchain development, making it much more intuitive for writing secure and efficient on-chain code. Solana, on the other hand, was developed using Rust, which is a general-purpose programming language that has a steep learning curve. Because of this, Move is generally considered easier to learn than Rust, especially for developers who are new to building on the blockchain. When you look at it like that, it's clear that SUI wasn't just uniquely built for mass adoption of consumers, but to onboard Web 2 developers as well. So if mass adoption is the end goal, Sui is positioned to be the blockchain that actually gets us there, because if Web 3 is ever going to reach the mainstream, blockchains need to evolve. They need to be faster, more scalable, reliable, and most importantly, user-friendly. Sui has positioned itself as the first real contender to bridge the gap between Web 3 and Web 2 adoption. So while players like Solana have dominated the last few years, it's perfectly reasonable to think that those might not be the blockchains that lead us into the future. And that's okay. Some blockchains walk so others can run.